Hello and welcome to my channel. I am Instructor Allison, and in this math video tutorial I want to discuss test of statistical hypothesis. The reason for which I decided to do or to make this video is because a lot of students have been complaining of gaining much understanding about this course, and of course so many said they have been reading from textbook, but the write-ups in the textbook has been complex. So I decided to make this video. So if you're new to my channel, please consider hitting the subscribe button and turn on the notification bell. The reason for which you need to turn on this notification icon is because I'm going to be making more videos on this test of statistical hypothesis. This first video is basically to explain the concept, and in subsequent video I'll be solving problems concerning test of statistical hypothesis. So by the way, I am Instructor Allison and I have been teaching math and science for a decade, and I am glad to instruct you on this statistical hypothesis. So let's get started. When we talk about statistical hypothesis, what exactly is this word hypothesis? A hypothesis is a statement about one or more populations. It's an assumption about the population involved. That means this statement about, let's say, this statement about the population may either be true or may not be true. So, but then the important thing I need you to know is that there are a lot of parameters associated with this test of hypothesis. But keep in mind that test of hypothesis is also called test of significance in case of necessity. So I would like to start off with the basic symbol used in inferential statistics, and then I will streamline it to this test of statistical hypothesis. Alright, the first one I want to introduce to you is this mu. And what exactly does this represent? This stands for population mean. So let's put it down so that it will help you to gain basic understanding about this course. And we're just mentioning population for the first time. So what exactly is this population? Population talks about the entire group of individual or objects under investigation or under study. That's what population is all about. So then the next symbol I want to introduce to us is this sample mean. We call this sample mean. Okay, this is mean. And then I'm just introducing the word sample. So what exactly is sample? Sample is a representative part of, or maybe call it a subset of a population. So when you think about sample mean or sample itself, you just have to think about the subset of a population. The next symbol I want to introduce is this one called the sample standard deviation. And the next one I want to introduce is this rho, and this is called the population standard deviation. If you're not able to differentiate between these symbols and know what exactly they stand for, that's the beginning of the confusion. So which is why I deem it necessary to start with identifying the necessary symbols used in this inferential statistics. So another one I also want to introduce to you is this alpha. You always see this alpha, and it represents what we call the level of significance. And most times you usually place it in percentage. All right. And if you want to talk more further, maybe it's not necessary. When the time comes, I want to explain why in most cases, but just know that customarily we usually use uh, take values for this alpha to be at 0.05, which represent 5%, or we use 0.01, which represents 1%. Right, that doesn't mean this is the only. They can also decide to use any other value for this level of significance. Right, but when you see also z subscript alpha, this is just for critical points. This is for critical points. And then you may see n also. This is for maybe when you have a random sample. In some cases you will notice that n is greater than 30, and in some cases you notice that n is less than 30. And when it's greater than 30 or less than 30, we have formulas associated with, or we should use, for either t statistic or z statistic. Right, some textbook also, they want to use this theta, which represents kind of a population parameter. It's just a parameter, and this parameter is always equal to some value, say it's theta naught. All right, so these are the basic symbols I want you to get yourself familiar with, so that by the time we start making use of them, you don't want to get much confused. So then I want to introduce you to the next phase, and the next phase is basically to introduce some formula. Before introducing formula under this test concerning mean, I want to explain some concepts under this test concerning means. And what are the concepts I need to introduce to you that will help you while we proceed along? I want to start by saying that in carrying out tests concerning population mean, of course I've introduced this to you already. We first state the null and alternative hypothesis. If these words are new to you, don't worry, we're going to talk about them. I know I was supposed to also introduce the symbols, but here we're going to treat them. So I'm saying that in carrying out tests concerning the population mean, which is this, we first state the null and alternative statistics. So I would just want to put them as steps you must follow. And the step one that I have stated is that you must state the null, and this null we usually use, some textbook uses H naught to represent null. So let's say H naught stands for null hypothesis. Right, and of course you're familiar with null. Null means represent something that is empty, and also some cases say 0, and as the case may be. So this is the symbol for null hypothesis. And I also mentioned another one called the alternative hypothesis. Some textbook uses H1 as the symbol for alternative hypothesis. Some textbook uses H subscript A. So either ways, when you see this or this, just know that the both of them are the same and they represent alternative hypothesis. All right, okay, if you understand this, so the first test we're going to work on is to, like I said earlier, if we talk about this null hypothesis, firstly, what exactly is this null hypothesis? is this null hypothesis is talking about currently accepted value for a parameter. All right, and then this particular one is talking about maybe it involves the claim to be tested. All right, another name for this alternative hypothesis, you could call it a research hypothesis, because we could have we could have a value, an accepted value here. All right, that is under the null hypothesis for a parameter, but here it has to do with the it involves the claim value here that has to be tested. If this particular value here is true, that's what this alternative hypothesis or research hypothesis is talking about. So for the step 1, I said that you must have to first of all identify the null and alternative hypothesis by saying that H naught is such that I've already introduced this symbol to you, so by now you should be familiar with this to be the population mean equal to population mean naught, right? And then if you want to check the alternate hypothesis, whether you want to use H1 or you want to use H subscript A, this will have about 3 conditions. It will have for two-tailed tests when this is not equal to this, and this is for two-tailed tests. I'll explain what two-tailed test is all about. All right, and then we still have another of this when the population mean is greater than this, and this we use this greater than is for when we talk about right tests. You just say right-tailed tests. We also have when this is less than this, and this is for left-tailed tests. And then whether it is right or left, the both of them together is what we call one-tailed tests. Right? So the both of them is what we call the one-tailed test. So apparently we have the two-tailed tests when we judge this, we'll talk about this, and then we have the one-tailed test when we talk about either the lefts or the rights. So I'm going to also use a diagrammatic representation to show what I mean by one-tailed test and two-tailed test. So if you want to sketch the two-tailed test, firstly, let's start with two-tailed tests. So I'll have this distribution, and then this is how I like to draw mine. So at this point, we will have two shaded region. I'll also have from this part, I will shade it down to this point. And if you like, I make it an arrow. That means this is going to the right infinity, this to the negative infinity. All right. So at this point, if you want to label, this is for Z, and then this particular region is what we call the non-rejection region. This particular point, you can have this center to be at this point. This Z is equal to 0. All right, and then we call this shaded part to be the critical region. And in some case, some book want to call it rejection region. That is also correct. critical region, or you can call it rejection region. Something applied to this point as the critical region or rejection region. I told you that at this point within this boundary, no rejection is a non-rejection rejection region, and this is what we call two-tailed test because it has both the left tailed and also the right tailed. So we call this two-tailed test. So you can have other parameters associated with it. All right, but at this point, let's leave it here. And then for the left test and the right test, we will have this distribution, and then if I have only this part shaded, which also is called the critical region and the rejection region, then of course here still remains the center, and this is the left because we shaded only the left part. That's why we call it left tailed. So again, we have another distribution of this kind. Just manage the diagram, and then we have this part shaded. So we call this here is the center, and this is the right tailed. All right, so this should be able to give us the basics of what two-tailed tells, and I've already said that whether we have it to be left or right, we call it one-tailed test. And what exactly is one-tailed test? It's just a statistical test in which the critical region or the critical area of a distribution is one-sided. Like in this case, this is one-sided, this one is one-sided, so that it is either greater than or less than a certain value, but not both. But if you see in this case, we have both critical areas shaded. So that's why we call it two-tailed, both the left and the right tail tests. All right, so that is enough for that step one. Then step two, you will need to determine the left right or two-tailed and sketch the graph. So that's the next step you want to do. After you would have engaged in the first step, the second step is to determine the left, right, or two-tailed and sketch. And when you're done sketching, you need to also consider this third step. And what exactly is the third step? You need to find the critical region. And when you find the critical region for accepting or rejecting the null hypothesis at the significant level, which is the alpha, you have to label on the graph, on this particular graph that you would have plotted. All right, so you want to write this down. You find the critical region for accepting or rejecting the null hypothesis. Are the significant. The significance level. And after you would have done this, make sure you label on the graph. For example, if I have this distribution like this, and then let's say I have a two-tailed test, I'll make sure I label the parameter I have on the graph. This is alpha over 2, and then I will also have this negative z to be alpha over 2. Also, this part is a negative part, this is a positive to infinity, so still have z at this point to be also alpha over 2. I always have the same value right from the left and the right, but the difference is that there will be a negative value and there will be a positive value. And here we have, this is the center, of course, non-rejection point. So here is always alpha over 2, right? So you must make sure that for two-tailed tests like this, after you would have found the critical region for accepting or rejecting the null hypothesis at the significance level, you have to make sure that you label all of them on the graph. So when you're done with that, the next step you want to engage in, which I'll call step 4, is to calculate the test statistic. For example, I want to present some formula that will be useful to you. For example, you have to use z equals the sample mean minus the population mean all over, use this rho, which is the population standard deviation, all over the square root of n. And this formula should be used if this rho, or let's use the main name, if this population standard deviation is known, right? Again, if this population standard deviation is unknown, then the test statistic is t equals the sample mean minus the population mean over the sample standard deviation divided by the square root of the random sample. And this works especially if n is less than 30. That's when you should apply this. But if n is greater than 30, then you need to use this formula that involves the sample mean minus the population mean all over the sample standard deviation, or the square root of n, and that's why we call this the t statistic, and this is the z statistics. Of course, we usually have a table that you will use when the time reaches when we start solving problems. In the next video, we'll talk more about that. So the next step you're going to engage in, and this should be step 5. In this step 5, you need to make a decision about the null hypothesis. So in this case, it's either to reject or accept the null hypothesis based on the stated critical region from the previous work. If the calculated value of the statistic falls in the critical region, let's use this to test run it. If it falls within the critical region, this is the critical region, we reject the null hypothesis and accept otherwise. If the calculation value of the statistic is equal to the tabulated value, we reserve the judgment and take more sample. That's how we use or we do the judgment. So keep in mind, in a hypothesis testing, we usually have 2 types of errors. And the first one is what we call the type 1 error, and we have also what we call the type 2 errors. So let's explain this briefly. What exactly is this type 1 error? A type 1 error is committed if we reject the null hypothesis when it is true. But in this case, a type 2 error is committed if we accept the null hypothesis when it is false. Then the probability of committing a type 1 error is called the level of significance of the test. And the level of significance of the test is denoted by alpha. So in essence, the probability of type 1 error is equal to alpha. Also, the probability of type 2 error is what we call the beta. But you should just take note that in testing of given statistic hypothesis or statistical hypothesis, the maximum probability with which we will be willing to risk a type 1 error is called the level of significance of the test. In practice, like we've stated earlier, we usually have the level of significance to be equals 0.05, which is essentially something as 5%, because when you divide 5 by 100, you should be having this. Or we usually have the values such as 0.01, and this is for 1%. All right. So these values I have given to you are customary, although other values are used. So just take note that the probability also of rejecting false hypothesis is 1 minus beta. This is referred to as the power of a test. So this is where I want to drop the pen and hope to have you in the next video, where I'll be solving problem using the necessary properties we've introduced. But before then, keep in mind that when the calculated value is greater than the tabulated value, what we need to do at that point is to reject the null hypothesis. Again, when the calculated value is less than the tabulated value, what we need to do is, at this point, we cannot reject the null hypothesis. And finally, when the calculated value is equal to the tabulated value, we reserve judgment. Or what we need to do at this point is to take more sample. So this is all from me to you, and I hope that you will hit the subscribe button, like this video, share to your friends, and also make sure you comment so we can be able to grow our channel and also have the algorithm checked for proper evaluation. Thank you for watching. I'll see you in the next video.